I was in Paris 2 weeks ago at something called AI Dev, a conference for AI developers. And I mentioned to the speaker that I thought he wasn't entirely up to date, because one of the best pieces of work I've ever seen in AI was what I called the Netherlands report. And you may remember when we opened earlier today, I showed you a grid with 14 things along the top and all the LLMs measured against them to look at the different pieces, the disaggregated components of AI and how those can be opened up. And I said this quite boldly. There's the Netherlands piece of work. And at the end, this gentleman turned around and said to me, "What are you talking about? What's this Netherlands piece of work?" And I told him, and he said, "Oh, I wrote that." So anybody who knows me knows that I couldn't miss an opportunity. So we got Andreas to come and join us today, and he's about to deliver you a keynote about open washing and the AI Act, which is the frame that grid that I showed you sits in. And I think it's one of the most important conversations not being had about the European AI Act. It exempts open source, and it's unclear what open source is. I'm going to hand over to Andreas, who's going to explain that to you, I think, better than anybody on the planet can at this point in time. And he's also written a short version of his report, his outputs in our report. So I would commend that to you too. Andreas, can I bring you to the stage?
Thank you, Amanda. Is this working? Yeah? Okay. All right. Well, thank you for having me. So I'm going to be talking a little bit about the current state of open source AI. So there's a really interesting situation in this field right now, where if you look across Europe, right, so take Germany, take France, take the Netherlands, there is quite some governance support. There is policies in place which promote open source, which foster the use of open source. And in one case, there's a piece of news I came across just last week about Switzerland, which, if I got that right, so it's even mandating the use of open source technology in the public sector. So this is nice, and this is we see this across many countries in Europe, that open source is encouraged, especially for people like me working at a public university. So I want to use open source. But then came along ChatGPT. So that's my field, and that's what had the biggest impact on academia and academic writing, and we had to engage with that type of technology. And of course, I want to use an open alternative to ChatGPT. And so the problem here on this other side of the interesting situation is that what does that mean, open source generative AI? What is the definition there? And I'm just going to mention two initiatives out of many initiatives of a great amount of people who have been addressing this problem and who have been working on sort of updating or translating traditional open source definitions and meanings into that age of generative AI. So one is a joint statement on safety and openness by Mozilla, and many colleagues working on that. And another one is the open source initiative's AI deep dive, which is still ongoing and which has as one of its targets to update the definition they gave, and which many have been traditionally following and looking to for different definitions of what open source means into the age of OpenAI. And yeah, that's still ongoing, and we have to see how this falls out in the end. So there's a final report, I think, expected quite soon. And so in between this kind of unclarity of what is the definition when it comes to this type of technology, and then also this support and this timeliness and this urgency that we want to use open source technology in the public sector, in public universities, and in many other sectors, of course, also falls our project. So this is joint work with my colleague Mark Dingemans at Radboud University in the Netherlands. And this is the Opening Up ChatGPT project. So after ChatGPT was released and made a wave, we went looking immediately for more open alternatives to that specific tool. So I'm talking about the type of instruction-tuned text generator, so that the thing that ChatGPT is, and quickly enough, many alternatives were sprouting up, and there were many, many tools which were populating this area. And so we looked at all of them, and we immediately encountered a problem, which is that we found it hard to even draw a line to which ones are truly open source and which ones are not. So we started out by just looking at those who brand themselves, right, who build themselves as open or open source. And we were looking around, and that's the kind of the self description that we took at face value at the time, and we looked at all those that claim to be open source, and then we quickly encountered that there's a lot going on under the bonnet with all these tools that are branded as open source. So what you're looking at here is an overview of the tools that we looked at. So all of these are instruction-tuned text generators of the type of thing that ChatGPT is. And each row is one piece of technology by a different organization that has built it. And each column is one aspect of openness that we found important. So we have identified 14 of them, and they come in 3 broad categories. Availability, so that is how available is this specific part of the training pipeline or of the data sets that are being used in the training pipeline. So one of the things that make instruction-tuned text generators special is that they are hard to train in the sense that they have a long training pipeline where you have to go through multiple steps of having to deal with some base model and then fine-tuning that model and then dealing with different types of data set for reinforcement learning steps and so forth and so on. And so we've tried to boil that down at least in some overview where we then looked at how can we retrace the steps in how this tool was built from the base model through different training steps to the reinforcement learning training steps that make them sort of instruction-tuned, to the licensing and so on. So that's availability. And then documentation is how well is that pipeline documented? How much do we know how this tool was actually built? And the third part is access. So access is about how can you interact with this technology? Is it available as a package maybe on some repository, or is there an API? How's the API managed, and these kind of things. And so the little boxes you see on this chart here are our evidence-based judgments. Either green means open, or yellow means partial, or red means closed. And so this database here is linked to a GitHub repository, which itself is, of course, also open, where people can go and they can update these evidence-based statements. So for instance, if one of these tools is evolving, there's a new version of it, then you can, so this table is can change, and we will see, we have seen quite some changes there already, where different models have been moving up and down. So what you see here is the top of the table. So the top few models here are those who, according to our survey at least, fare quite well when it comes to openness. And so they've opened up most of the information and the technology and the tools about how this technology was built and how you can interact with it. And those more towards the bottom are those who are less open. We also put ChatGPT here on this slide, which is the only one which, of course, doesn't brand itself as open source. Still, as a reference, you can see open source as the original perpetrator of kind of overclaiming how open they are, fares quite badly with their ChatGPT tool. And so the takeaway from this type of work, where we've been looking continuously over the past year or so at this technology landscape, right, is that in generative AI, openness has to be composite. So it has to be made up of different individual slices of this technology that you have to look at. So there is no just one individual data point that would suffice when we want to classify this technology as open or not. So you have to come up with a spectrum of individual metrics that you, or individual dimensions that you look at. And these might differ a little bit if you shift the focus, for instance, to text-to-image generator, so that's another type of generative AI. And then these 14 dimensions might look a little bit different. Maybe they will be 15 instead of 14, maybe 13, something like that. But you will still have a substantial composition of individual dimensions that you have to look at. And the second insight that we gained is that this is necessarily gradient, right? So just boiling this down to a dichotomous yes, open or not open statements did not suffice. And so we went through with a three-stage level of making statements, whether something in one dimension is fully open, partially open, or closed. And even there, we felt we are being quite reductive already. Yeah, so to highlight some insights here. So one kind of surprise find that we came across is if you look at the reinforcement learning data, so that is a specific type of data set which enables the instruction following capabilities in these type of models. So specifically there, we found there is a strong tendency to underreport the specifics of what data was actually used. So when we looked at all of these models, we found that, for instance, in the reinforcement learning data, a lot of companies use something that we call a release by blog post strategy. So they only release information about what data is being used in a blog post. So this is nothing like a peer-reviewed academic publication. There is no safety net such as a peer review, nothing like that. It does look a little scientific in many cases. There's lots of figures and numbers. But the amount of detail that is often included in these blog posts is minimal. It's really, really minimal. And so that is one trick in the playbook of open washing technology, right? So release a blog post and include as many fancy figures in there, but as little as actual tangible information in there. Another thing we found is, by the way, that, for instance, academic publications, right? So that's the fully red column there, has completely fallen out of fashion in this field. So there is very few tool builders in this field who actually still publish academic papers. All right, so then if you have a multi-dimensional table like this and you have gone through all that work and you have collected all these insights and you have a platform where this can be tracked, how open these models are, how do you turn them into actionable measures? Well, the first thing you can do is you can compute a gradient. You can just calculate a gradient based on how open a model is, and you can assign that a score, 20, 40, 60, 80, 100, something like that. You could also then come up with a kind of a discrete labeling system. So this looks a little bit like the energy labels which are used in the EU. I'm sure there's something similar in the UK here. So you could turn this into a labeling system like that. And you could turn it into a dichotomous measure, right? So you could just draw a line somewhere and say, okay, this is the line we draw, right? So everything past this line is open and the others are not. And this is exactly what happens. Okay, there's something missing here. Okay, so this is exactly what happens when it comes to a phenomenon that we've seen, which is called open weights. Right, so models that are open weights only just focus on one column, which is the model weights, and release this piece of information, this piece of their technology, just the weights, and then still go around and collect brownie points for openness, even though if you look horizontally at the other dimensions of openness, you find out that many other aspects of these systems, of such a system, remains actually completely under wraps and no information is being shared whatsoever. So yeah, this is another trick out of the playbook of open washing. And so in a recent paper, we have focused on how that relates to the EU AI Act. So in the EU AI Act, open source technology is treated differently, which I think it's fair to say adds some legal weight to a definition of open source and what it means to be actually open. And as I've shown, this is not an easy an easy task, and it's quite hard to really draw that line through such a big field of technologies in a way where you steer attention to those technologies or those builders of technologies that actually deserve it, and keep the bad apples out. And we see there's lots of movement in this field, and I hope this line will be drawn in the right way, also in the UK and in the EU, when the EU AI Act takes its final form and is actually implemented. And yeah, this is all for me. So you can find more tricks out of the playbook of open washing in that paper, scanning this code. And I thank you very much for your attention. And thank you, Amanda.
Thank you.
Andreas, I think that's absolutely brilliant. Open washing. We talked about open washing at the beginning of the day in the context of open source software and the software that the open source community would have called proprietary, but which is actually not open source. And we now have this challenge around how the term open source is being used for AI.